Alright guys, welcome back. Today we're going to talk about surface area of spheres. Now, same as volume, the formula is a little bit beyond our knowledge. So we're not going to go over why it's 4 pi r squared. Okay. So in this case, it's quite straightforward. The only way to understand it in our case, for now, is just to memorize it. 4 pi r squared. I guess it's not very hard to memorize. So I know it might be disappointing for some people not to be able to find out why the formula is 4 pi r squared. But if you like, you can notice some of the patterns in the following. Now, first of all, let's start out with the circle circumference formula. This is probably the first thing that we learned in elementary school, is 2 pi r. And then we move up to the area, and someone told us that is pi r squared. And then today, we learned about the surface area for a circle, for a sphere, which is 4 pi r squared. And then we also talked about the volume for a sphere, which is 4 over 3 pi r cubed, in this case. Okay, so let's find out some pattern in this case. We'd like to bring these two into a group, and I'd like to put these into a group. Okay, so let's talk about how they actually relate to each other. If you look at area, okay, if you want to downgrade yourself to circumference, okay, basically that means if you want to bring yourself from 2D to just 1D, circumference is only the length, right? So we're talking about only the length. So we want to bring your area down to length. How do you change your formula? Right, your formula started from area, which is pi r squared. Okay, this is how you actually change from a formula of area to a formula of circumference. Right, what you do is you bring the 2 down here, okay? And then the 2 that you're having over here originally doesn't disappear, actually. It got subtracted by 1, okay? So what you get in this case is 2 pi r to the power of 2 minus 1. 2 minus 1 is just 1, right? So this is 2 pi r to the power of 1, right? But this is basically just 2 pi r. So the next case, we're having volume being transformed to surface area, right? So how does that work? It actually works exactly the same way, okay? So you start from 4 over 3 pi r cubed. So what we're going to do is we're going from volume. This is a formula for volume. We're going to go from volume to surface area. So again, what we do is also, okay, we bring the 3 down here on the floor. It becomes a multiplication now. And then what we had originally, the 3, it doesn't actually go away. It's still 6 there, but then again, it also got subtracted by 1. Okay, what we're going to have over here is 3 times 4 over 3 pi r, 3 to the power of 1, which is r to the power of 2 in this case. Okay, so what we're going to have is 3 times 4 over 3, which is equal to 4, okay, because 3 and 3 can cancel out. 4 pi r, 3 minus 1, it's going to give you 2. Okay, so 4 pi r squared. This whole process over here is actually part of the calculus concept that we will be talking about in the future, called differentiation. Okay, if you don't know what I'm talking about right now, forget about it. So let's go through 3 examples for today. The first one is pretty straightforward. All we need to do, again, is just plug in the formula. So surface area is equal to 4 pi r squared. R, very clear, is equal to A. So 4 pi 8 squared. The answer is approximately 804 centimeters squared. And that's it for this question. Now the second one, we also want to find out the surface area, but this one's a little bit tricky. This is actually part of the sphere. To be precise, half of it, right? We only take half of the sphere, okay, from the bottom. And then in there, for the meat, right, we are taking an area of a regular circle with diameter 11 in this case. Yes, you're right. It actually looks like a watermelon. Okay, so how do we find out the surface area of this watermelon? Right, you gotta take care of the peel, the green part, and also the surface meat, the meat on the surface. Okay, so what would that be? In that case, that would be, first of all, let's deal with the peel, right, the green part. That's basically half of the surface area of the original sphere. So you will have 4 pi r squared, but then in this case you only have half of it, so that's why we divide by 2. And then we plus the red part, right, the actual watermelon. So what is that? In that case, it's basically just a pi r squared, because it's basically just an area of a circle. So we have pi r squared. Alright, so what you can do is you're basically done. In this case, our r is 11 divided by 2 is 5.5. Right, you can plug your r into this expression, and then you will be able to find the answer. But if you want to do some simplification before you actually plug in, this will actually be very cool, because what happens is the 4 divided by 2 actually will give you 2 pi r squared, and then you have another pi r squared sticking around at the end. What happens is this is actually simplified to 3 pi r squared, right? So you can actually just plug in the formula with the 3 pi r squared. So you plug in 5.5, in this case we got 3 pi times 5.5 squared, and you will get your answer approximately 285 centimeters squared. Last question of the day. We have a sphere that has a surface area of 1134 centimeters squared. We want to find the volume of the sphere. So let's go ahead and write down our formula. Okay, so for surface area, we have 4 pi r squared. Right, for volume, we have 4 over 3 pi r cubed. Okay, so that's all we know for now. Okay, but what they give you is only the value of the surface area. So we plug that in. Okay, so that basically means your 4 pi r squared is equal to 1134. And what we want to do first is we want to find out the value of r. So we want to solve for r. So we're going to have r squared equals to 1134 over 4 pi. Okay, notice that the whole 4 pi should be downstairs. When you punch into the calculator, make sure you put a bracket around it. And this is basically a typical question for solving for, k squared, x squared equals to k. So we did that before. When you solve that, what you get is basically you put a cap on it. Right, so 1134, 4 pi. You should ideally put plus or minus, remember? But in this case, because r is length, right, we're talking about the length, so it is impossible for your length to be negative. So we're going to just take out the plus or minus. Right? There's no such case that has minus. So in this case, we're only going to consider the plus case, okay, which is the same as just writing nothing. So you punch this into a calculator. Surprisingly, that gives you a pretty nice number. This is almost very, very close to 9.5. So your r is about 9.5 centimeters squared. And once you know your r, you're basically done, because all you need to do is, if you want to find the volume, just plug it in. So you have 4 over 3 pi r cubed. In this case, your r is just 9.5. Okay, so you plug it in, your answer is around 3,591 centimeters cubed. Guys, in this case, my unit is centimeters cubed. For surface area, the unit is centimeter squared. So make sure you know the difference. Otherwise, that's it for this question. And that's it for today. I will see you guys tomorrow. Peace.